In this next few example, we are going to look at definite integrals, but we are going to be looking at definite integrals with trigo integrations, ln integrations, and also exponential integration. So essentially, the technique will still be the same idea. You will still need to integrate, and then you do a top minus bottom. So it will be the same idea. So generally, definite integrals will be like you integrate, which using whichever formula, then you do a top minus bottom to get the values, and the values will represent the area under graph. Okay, however, if you are doing trigo, you will need to assess it in radial mode. So the question will not tell you. So it's an automatic kind of thing that you need to do it in radial mode. So for example, here, integrate cosine x with from pi over 6 to 0. So if you integrate cosine, that will be sine. So you integrate first, and then you do a top minus bottom. We try to not to press everything at one shot. So try not to press everything at one shot. So you press item per item. Okay, so try to press item per item in case you might need to leave it in the exact form, or you might need to leave it inserts. Okay, so integrate secant square. According to formula, integrating secant square is a tangent x. So integrate, then you do a top minus bottom. So, and you press one by one. This one is a 1. This part is a 0. So overall, you get a 1. So common mistake will be sometimes some students, they will forget to integrate, and they directly do a top minus bottom. Okay, so do remember, integrate and do a top minus bottom. So when you got a constant like this 1, when you integrate, it's still the same formula. Integrate constant is a x. So integrate sine will be minus cosine. So integrate first and simplify. So usually I will prefer that you simplify, then you do a top minus bottom. So when you do a top minus bottom, please be very careful. That's where careless mistake will usually appear. So like I say, press item per item. Okay, why do I say you press item per item? Okay, so pi over 2. Okay, you press out this part. If you press out this part, it will get you a 0. So if you press out this, it will actually give you a 1. But if you don't press out, you will assume that it's a 0. Some people assume that cosine 0 is a 0. So that's also another careless mistake. So overall, this is what you will be getting. So this will be your answer if you need to leave it in terms of pi or leave it in the exact form. Otherwise, it will be your 3SF answer. So for definite integral, sometimes you will be asked to leave in terms of pi or leave it in exact form, which most probably will be special angle. So you need to press item per item. Don't try to press everything at one shot. So in the next example, we are integrating the exponential. So go back to your integration of your exponential formula. So in this case, I will be doing a 1 over a e ax plus b. So I'm doing my integration. I simplify my integration. Then I do a top minus bottom. So do it carefully. So do a top minus bottom. Then you can punch calculator. So if you punch calculator, you leave it in 3SF. Okay, so everything will be the same thing. So back to your integration. So here my A is -2. Okay. So be very careful when you got a negative. So do a top minus bottom. And don't be lazy to write it out. So some students, when they do definite integral, they are lazy to write out the top minus bottom. So they didn't write out whatever they are subtracting. And then they just gave a numerical value. And when they are wrong, they couldn't know what went wrong. So write out whatever you'll be pressing. Okay, then you can punch calculator. Okay, so if you don't write out, and when you get it wrong, you yourself usually cannot check. And when you ask me, why is it wrong? So it should be your calculator issue. If let's say you are able to integrate correctly. Okay, so don't be lazy to write out the top minus bottom. Okay, so same thing here. So integrate first. Then you do a top minus bottom. And same thing, sometimes, right, don't press everything at one shot. So maybe you can press this first. If you press this, it actually gave you a 25. So you integrate and you do a top minus bottom. So it all lies with, are you integrating correctly? And when you do the top minus bottom, are you punching your calculator correctly? For exponential, there's no need to put it in radian mode. There's no angle involved. So it doesn't matter whether is it in radian mode or not. Same for long function. Same for long function. Okay, so here, if you integrate this, you can pull out the numerator first. It doesn't matter whether you pull out the numerator or not. So by now, if let's say you can tell that you actually get ln x, you can do it this way. So you will get something like ln 4 minus ln 1. So you can do it this way. You get 5.55. Or some students, if they can tell directly, they can if by now you already can mental integrate 4 over x is 4 ln x. You do a direct 4 ln x, and then you do your definite integral. You will still get the same answer. Okay, so either way will do. Okay, so the next one. So this one, integrating 2 is a 2x. Integrating this will be minus 3 ln x. Okay, so if you can do it direct, you can just do it this way, and then do a top minus bottom. Okay, so usually I don't prefer to press directly. I will just try to simplify as much as I can before I press. Okay, so in fact, if you open up the bracket here, you will have a 8 minus 4. Then after that, I go for the pressing of calculator. So I'll get 1.92. So alternatively, some students, right, they might prefer to split them up. So I show you another way. So both are correct. So some students, they prefer to split them up. They prefer to do something like this. So under the property of definite integral, yeah, you can do it. You can split them up. Split into two separate integral. Then you do this. And you do this. You will still get the same answer. So you get 8 minus 4. Here you will get ln 4 minus ln 2. So you punch your calculator, you still get 1.92. So you can directly integrate and just do it as a whole integrate, top minus bottom, or you can split them into two. Split them into two, and then you do a top minus bottom twice. So you do a top minus bottom for this. You also do a top minus bottom for this. So it's your choice. The numerical value shouldn't change. Okay, so the same thing for this one as well. So this one you can pull out first, because the condition of the formula will need the numerator to be 1. So you can do that. Then you got a 1 over 2 ln 2x plus 1. You can multiply in the 2, you can bring out the half. It doesn't matter. So when you multiply in the 2, essentially you just got this. And then you do a top minus bottom. So you will get a ln 3 minus a ln 1. Okay, so this one is just applying formula. Keep applying formula, keep integrating. And then you do a top minus bottom. So nothing much changes. You are going back to the formulas that you have learned in the previous teaching worksheet. Except that do remember, when you are doing it for trigo, your calculator has to be in radian mode, or else your calculation will go wrong. But your integration, you will get marked for integration if you forget to change the radian mode.